Hi, have you ever wondered how you can get your sketch that's normally running on your Arduino development system to run on just the chip on a breadboard? In this short tutorial, I'll show you how to do it. This breadboard is running a simple blink program, which I've modified very slightly just to make it slightly more interesting. This is the sketch that I've used. As you can see, I've taken the normal blink program, added a couple of loops so that the LED will blink some long blinks and then a few short blinks. When you upload this sketch to your Arduino board, this is what you'll see. As you can see, the LED is flashing three long flashes and then quite a few short flashes. Then it goes around the loop again. If you can't see that, I'll just add a LED to the breadboard to show that in more detail. So here I've got an LED and I've soldered on 150 ohm resistor, and I'll just pop this into port 13 on the board and down to ground, and there you can see. You see the sketch working. Right, now how do you get from this development board, which has got a lot of supporting circuitry, to a breadboard? Well, it's quite easy really. There's a few external components you need to make sure the chip runs. You need a clock in the form of a crystal, some power rails, and that's all really. And I'll just go through the steps very quickly now to show you how to do that. First of all, here's a circuit diagram showing how to wire up the ATMega chip that will support your sketch. As you can see, we've got the crystal, which goes across pins 9 and 10. Either side are brought down to ground through a 22 picofarad capacitor. Anywhere between 18 and 22 picofarads will work. The reset switch is pulled up through a 100k resistor, and a switch will bring that down to 0 volts to reset your Arduino, or rather your ATMega. Digital pin 13, which is used on the blink program, is over here and is actually on pin number 19 of the chip. That is driven from pin 19 down to ground through a 150 ohm resistor. Very simple circuit, so let's get building. So, starting with your breadboard, it might be best to put your chip in first. I do this by gently levering out the ATMega chip from the socket. An extraction tool is preferable. Go along the whole length as far as you can to avoid bending pins. So I'll position this. Pin 1 is here with a little dimple in the corner. I shall position that on the breadboard, making sure all the pins are in. Just for simplicity, I've put this in at row 21. Now, looking at the diagram, we've got some Vcc connections that we need to do. So let's do some of those first. So pin 7 goes to Vcc. Let's put him on over there. Then we've got a ground on pin 8, which is the adjacent one. If you're not familiar with breadboards, you can see I've got a ground line, negative line running down here, positive down here. These will be 5 volts, 0 volts. We need the crystal going across pins 9 and 10. With a slight twist you can get them in. Just be careful, this is conductive material on the outside of the crystal, you don't want to short onto any of your pins. Then you want the 2 capacitors either side of the crystal to go down to ground. There's one. There's the other. So this is the clock circuit. Add a resistor to pull the reset button up to positive. Reset button is pin 1. So that's 100k in there. And to actually reset the chip, we'll use a momentary button. So what we need to do is connect that to pin 1. In fact, let's move him up a bit further. So he will go in there. When you press the switch, these 2 pins will be shorted. So we need to take the top pin to ground. It's this. So we've got our VCC, our ground, our crystal, 2 capacitors, and a very simple switch circuit for resetting the chip. And finally we want to see something happening, so our digital pin 13, as in the sketch, is actually pin 19 on the chip. This is the same LED that I used on the Arduino board, same configuration. So we want to go from pin 19 to ground. Across to ground, we've got ground running over this side of the board, and that should be our sketch. Of course, what we need as well is some power. So what I use for convenience is one of these little breadboard compatible power supply units. It accepts a USB connection as in your different type as on your Arduino board, or a power supply input. And it's quite handy because you can set this to 5 volts or 3.3 depending on which chipsets you're using. So I've set this to 5 to run down this side, and I should obviously need, well, I don't need 5 over this side, I just need ground, so I can leave that on 3.3, it doesn't really matter, I'm just using that as ground. So that goes in to the breadboard. Then I've got a 12 volt supply which I shall plug in here. Then I should turn on the power supply, and this power supply board has got a convenient little push button which we push down to get power, and hey presto, we got the same blink program working in the ATMega chip, but it's now running on a breadboard as opposed to your Arduino development board. Now this is great as your stepping stone to then developing your project and then putting it onto a PCB or a Vario board for then boxing up and releasing it to the public. Thank you.